Hello everyone. Welcome to another day of daily LeetCode live streams. We're here to start right where we left off from yesterday. We're currently on page 3. We only have 4 more questions to reach our 200 question mark, so it's pretty phenomenal. We have been making steady progress, something I'm very happy about. If this is your first time here, whether you're watching on YouTube or Twitch, make sure to follow me, leave some comments, interact with me. I like getting the whole community involved. It's a lot of fun for me to be able to reach out and talk to you all. So I hope you've all been following with me since day 0. I have been doing this without fail every single day, doing some form of stream of me just going through all these LeetCode questions. If you want to start from the beginning with me, you can go ahead and navigate to my YouTube page. Here you're going to see a playlist called LeetCode Live Easy Collection, and you can just click on this first video and you can go through all the videos since that first day. Sweet. So without further ado, let's just go ahead and get started. Today we are going to be starting off, let's see, with occurrences after Bigram. Hey Rashawn, how you doing? Yeah, my day's been going pretty well. It's been a pretty tiring day. I feel like a lot happened at work today, so my brain's just a little bit fried. But it's just some days are like easy going, other days are a little bit more difficult, but overall things are going pretty well. I hope the same for you. Hope everything is going well for you. And yeah, good to see you again. All right, so let's see. Given 2 strings, first and second, consider occurrences in some text of the form first, second, third, where second comes immediately after first and third comes immediately after second. Return an array of all the words third for each occurrence of first, second, third. So first is A and second is good. So they just want third. So anytime I see a good, then I just return the third thing. So we will, right? So we will, and then we will rock. Okay, so really, at any point that we see, because we're always going to have a first and a second. So, one way that I think of doing this that I think will make it a little bit easy is to split the word. If we can assume that everything is separated by a single space, which it is, one thing I'd like to do is separate out all these words just by a single space, and that way we get a token of each, and we start looking through the array like this. But I'm sure there's maybe a more clever way. Like, can I just look for any indices where we will happens? I feel like I've seen people do that. They will like concatenate both of these, and maybe they'll look wherever we will happens. But then that's not necessarily going to give me the third thing. So let's see. We want pretty much, yeah, I think what we can do here, I feel you, it's been the same this week. Yeah, some weeks are just better than others, so that's how it is. All right, sweet. So what I want to do is I'm first going to split this word by space. So let's say split is going to be text, and I think actually we can just do text.split. Can do this for let I equals 0. Now we want to go up to what? Because you always want to look 2 ahead, right? So because of that, we shouldn't go to dot length or -1, right? We want to go to -2. So I less than split dot length -2. I plus plus. So here we can say if, let's see, if split of I is equal to first and split of I plus 1 is equal to second, then here we can just say our result, or rather maybe we'll just say occurrences, just to keep it in line with the name of the method here. We can say occurrences dot push split of I plus 2, and we can return occurrences here, right? So let's just go through this one right here. So imagine we're starting at I right here, right? So we say, is this first one, if split of I is equal to first is A, so it's not, right? So we continue to the second one. Is it equal to A? It's not, so we just go to the next one. Okay, I is equal to A. Is I plus 1 equal to second? Yep, so I plus 2, we make this first one girl. And then now we go to the next one. Good. That's not equal to first. So we pretty much just keep going until we get over here. So let's say like right over here, is I less than split dot length minus 2? Yeah, because the dot length is like out here. Minus 1 is here, minus 2 is here. This is less. Split I equals first, which is A, plus 1 is equal to second. So we can just return plus 2, which is student. Or not return, but push it to occurrences. And then that's it. And that's where we end. So let me go ahead and remove all this. Let's run this code. Let's just go ahead and do it for all of our test cases. So girl, student, and we rock, we rock. Let's sort of think about maybe other test cases. We always want it to be for both, right? I think this is probably fine. 47.22. Yep, feel pretty good about this one. I mean, I feel like it's a standard question. The one thing that maybe we can get a little bit better at is instead of splitting it ourselves, maybe we can just loop through this and we'll sort of keep track of all the pointers and we'll always know where we are. Frankly, that just makes it a little more difficult. I think in the real world, like in a coding interview, I might take advantage of split because it just makes the code easier to read. And for me, readability is always more important than cleverness, unless it offers us a significantly greater performance gain, which I'm not sure is the case here. 6.25. I'm going to run it like one more time. $70.14. All right, let's go ahead and check out the discussions. I think it's good for us just to read up on different solutions. So C++ search for bigram, split string, split the text into words, array, then loop through it to check previous two words are first and second. If yes, add current word into list, okay? Or brute force. All right, so they're saying that's the best version. A string stream, O of n. S word, answer pushback word, string stream. Nice code, Sasuke. Pretty cool. I haven't really seen that one before. First compose our bigram as first plus second plus. Thanks for that advice. Add an extra space in the end. We search for and add an extra space in the front of the original text. We don't match Alice jumped to list jumped. Thanks SmartDroid for the find. Search all bigram occurrences, extracting the word that follows. Runtime O of n plus m, where n is the size of the string and m minus size of the bigram. Searching for an additional space is better. Okay. Yeah, I mean, I think that's also pretty neat too. I'm happy with both solutions, and it seems like the community is also feeling the same way, as this one's not actually the highest voted one. So I feel nice about the solution we came up with. So yeah, let's just go and do the next question here. All right, so another binary tree traversal. Of course, the follow-up is going to be to do it iteratively. That's, you know, it just seems like to be the case with these. This one was, I think we've already done in order. I tried to do post order iteratively, but I wasn't able to do so. Let's see if we can figure out how to do it with pre-order. So pre-order will do 1, 2, 3. So if we think about the stack space here, I think a very important thing for us to do here is we need to draw this out, right? So if we think about 1, 2, and 3, let me just draw 1, 2, 3. 1, 2, 3. Okay. If we just draw this out, and as we're going through this, let's imagine that we're just doing this recursively, and let's think about the stack space every single time. In pre-order, we always visit the node first, and then we go left and right. So here we push 1 onto the stack, and then we push the left one onto the stack. In this case, it's null, so we pop off the stack, right? But actually here we've already printed this out, so I don't even think, yeah, we should immediately print this out as long as it's not null. We push the left one, but then we pop, we come back here, then we go to the right. We immediately process this one. In this case, we'll log it, or we'll append it to our result array. We'll come over here to our left. It's not null, so we can do the same thing again. So it's always a matter of like, how do we now take that and make it code? make all that into code, right? So imagine we have like a current pointer, and this just points to the node, or rather the root node. So the first thing that we can do is we can say push current node onto stack. And then we process it immediately. I think we can just say process if not null. Now, do we want to just go left? Do you want to see how left we can go? Maybe we can just say, maybe we can just actually keep doing this until, like, what if we say let current equals root, and we say while current, can we just append current dot val and current equals current dot left? Because what would that look like? We push one, we go current dot left. This is now null. So really what we should do is maybe we should pop off the stack. Imagine we have some stack like append, right? So as soon as it's null, this loop will end. So maybe here we can get node is something like pop. We can, to our result, we can push node.val and then current equals node.write. That will put it here. And then let's see, if we start this whole thing over again, while current, append current.val to current.left. We'll see, we don't want to just append it, right? We need to actually print it. So I think I should actually maybe push it here, but I can still keep that in my stack. I think that's one thing that we can do. Again, I wish there was like a nicer way of doing this. I'm gonna try and figure something out here. I'm gonna draw this thing down here, sort of representing our stack. And then I'm gonna take this bar. Oh wait, that's a line. Let's take this thing. These are gonna be like individual stack frames, right? Like we start at 1. This would be like our 1 right here. And then we keep the 1 around, but now we're gonna go to our null, which is to the left. We pop off this one. We come back to the 1. We print out 1, and then we push 2. Right? We have 2, we immediately print it. Then we push 3. Then we push null. We pop that. Okay. And then we try to go to the right of 3. That's null, so we pop that. And now we're back here. But I feel like at some point this should be, like at this point we would just start popping all the way, right? We'd be done with all this stuff and then we're done. But see, for me, it's always like, how do we, like putting this into iterative code is difficult. It's always like, or maybe not, maybe I'm overthinking this, right? Maybe I should instead try to be a little more high level here. Maybe instead of writing all this stuff out, maybe I should just think what, like if current node is not null, then we can append to our result. Append to result. And then what do? We go left. We go left as much as we can, printing out every single time. But wouldn't that be the same? Oh, I guess it would be sort of like, yeah, wait, it would be like the opposite of the in order, sort of. Because the in order, we're going left all the way. And then we're popping, we print and go right. Here we print, go left as much as we can, right? Like I'm almost thinking something like, let me see. What if we had const result, const stack. while something. I'm just going to put while, well, I'll just leave it like this for now. I haven't figured it out. It's not going to like that. So I'm just going to put while true. What is it that we want to do, right? Here we should say let current equals root. Like while current, we could say result dot push current dot val stack dot push current, and current equals current dot left. Right, like we push, and it'd be nice. Again, this always kind of gets in my way here. Let me just move this. Let me delete all this stuff. Let me delete this. It would also be nice if I can actually, like, I need to make this tree larger. It just doesn't work when it's like, this is too contrived of an example. That's like a big issue with these. So let's make this like 5, 2. We'll make this 7, 6, and 9. So we print 5, then we go left, we print 2, we go left, we go back to 2. We don't do anything though, we just go to 2's right. And then we can start that whole process over again. I almost think that's it. So print 5, go left, print 2, go left, null, so go to 2's right, and then null, so go to 5's right. So I guess really anytime it's like null, we just pop and then we can start the whole thing over again. I think. So while current result.push current.val stack.push current equals current.left, we're at 2. Result.push current.val, that would be 2 current.left. This is null. So when we're at null, which is current, do I just try to go to, let's see, const next node equals stack.pop current equals current.right. So what would happen here? I push 5, I push 2, I come here, this while loop breaks, I get the next node, which is 2, I try to go to its right, that's null. Right, so current is null, so next node is stack.pop, which is 5, current now equals 7, so while current we push 7, this might be it, maybe, but let me keep going through this. So we push 7, we print 7, we push 7, go to the left, we print 6, push 6, go to the left, this is null, so now we get 6, we try to go to its right, okay, that's null, so we get 7, we go to its right, okay, that's fine, so we print 9, we push 9, we go to the left, we go to its right, okay, while current, but now here, while true, if stack, perhaps here we can say if stack.length equals 0, do we just break? Return result. Let's try it for the original one that we had, right? 1, 2, 3. I'm gonna undo a lot of stuff here. Okay, so let's remove all this. Let's copy this over. Okay. Now I want to do like what I always do, right? I'm going to go ahead and start drawing out like my result and my stack. Okay, so we're right here in the beginning. So this diamond represents my current. So while true, okay, while current, result.push current.val, so this will be 1, stack.push 1, current equals current.left, now we're right here. While current, this is false. If stack.length is 0, it's not. So now we say const next node equals stack.pop. So we pop 1. That becomes next node. Current equals ones.right, which is 2. Okay, so current, yes, current is true. So we push 2. And stack.push 2. Current equals current.left. We add the 3 here. Now we push 3. We go to the left here. Right, we get to now here. If stack.length, right, it's not current anymore because it's null. Stack.length is length of 2, so this isn't true. Now we pop 3. Right, we go to 3's right, which is null. Now we start this thing over. This again is false. This is also false. We pop 2. We go to 2's right, which is over here. Now this is false, and we see that stack.length is 0. So now we just print out 1, 2, 3. 1, 2, 3. Yeah, I'm just gonna go for it. I think there might be something a little bit nicer that I can do, but let's see what this gives us. Current.write, next node, here we go. Next node.write. One, 2, 3, 1. Okay, so all our test cases passed. Let's see if we submit. Nice. Okay, that feels good. So like, that's the thing, right? If we figured out how to do in order and pre-order, so like we should be able to do post order, right? I don't know why that one's being a little bit more tricky. But yeah, this is good. This is very good practice. This is a very, very good question to go over. And I really hope for anyone that was watching my drawing right here. I know, again, it's like these drawings, again, what's the point of the stream, right? I really want you all to see and hear me struggle through this and come up with like different designs and show you all through my thought process. So I really hope that these drawings help. Sweet. All right, so that's good on that one. I feel pretty good about that. Let's go back to our problems. I think I closed that tab out. So let's see, we're only 2 questions away from 200. Are we gonna hit 200 today? Maybe. Let's go back down to page 3. Oh, what's up, Nelson? Good to see a new face around. Is that Figma? No, it's not actually. It's like it's an online whiteboard, I guess you can call it. It's called Excalidraw. I can go ahead and drop it on the chat. Yeah, excalidraw.com. It's just like an easy way, and I feel like the chat box is kind of getting in the way here. Let me see if we can move that a little bit. Yeah, it's just like a nice way for you to just like draw anything, really. They have a ton of different options, a lot of different shapes you can use, so I think it all works out pretty nicely. All right, so the next one is distribute candies to people. We distribute some number of candies to a row of n num people in the following way. We then give 1 candy to the first person, 2 candies to the second person, and so on until we give n candies to the last person. Then we go back to the start of the row, giving n plus 1 candies to the first person, n plus 2. All right? Start of the row after we reach the n until we run out of candies. The last person will receive all of our remaining candies. Return an array of length num people and some candies that represents the final distribution of candies. So we have 4 people on our first turn. Okay, I see. So 1, 2, or we have 0, 0, 0, 0. So here we give 1, then we give 2 candies. Oh yeah, let's think about this. Candies is 7. Maybe there's an easier way since I have candies right now. I can probably just take advantage of candies. But then I'm going to need something else anyway. Yeah, let me see. Like, I have candies, and let's say I have distributed candies equals 0. So if we're like on I currently, we're going to give them distributed candies plus 1. So we'll make this 1. Here, we're going to give them distributed candies plus 2. So we'll give them distributed candies plus 1, and then we'll subtract, right? We'll add 1 to distributed candies and subtract 1 from candies. So here, we want to give them 2, right? We could give them 2. Here we want to give them 3, and let's make sure to say, okay, we've distributed 3 here. Here we want to give them 3. Is that the case? 1, 2, right? Because we're always giving them on the second turn, and their array is 1, 2, 0, 0. On the fourth, answer plus or equals 1 because there's only 1 candy left. Right, we've given them 3. We now can only give 1. Like we'd like to give 4, but we only have, yeah, maybe I did this the opposite way here. I think I did this wrong. Let's come back here to the beginning. Let me just use this Candies one right here. We have 7 candies. Okay, we can give them 1. That's going to make it 6. We can give them 2 here. That's going to make this 4. We can give them 3 here. Right, I'll make this 1. Now here we'd like to give them 4, but we only have 1. So like if we go back to here, we could give them the amount because we have, so we can give full amount if current amount is less than or equal to candies. Right? Current amount is 3, that's less than or equal to 4. So we can give them the full amount, which will be 3. That'll make this 1 left. Now we come here, we'd like to give them 4, but 4 is not less than or equal. So in this case, we give them candies amount. Else we give them previous candies plus 1, subtract from total. So I'm thinking about doing something like that. And then our I, what we can do is we just, anytime we reach num people, so if it's like, let's see, 0, 1, 2, 3, anytime it's equal to 4, I think that's the easiest way, right? Using the modulo operator so we can continue to go in like a circular loop, right? So if we get to 4, let's see, 4 modulo 0 is, oh, maybe it needs to be, yeah, no, 4 modulo 4 is 0, 4 modulo 5, maybe it needs to be 5 modulo 4. Yeah, there you go. 4 modulo 4, 6 modulo 4. This will always give us the index. So let's see. This is, I think what we want to do, it's a couple things I need to do here. Let's say let person index equals 0. Here, really what I want to do is I want to say while candies is greater than 0, person index equals to 0 while candies is greater than 0. We can say, I guess we can say that total candies is equal to 0. So what do you do? Let's now think about this first one now. Now, do we need to create a new array? Return an array of length num people. I guess here we can say some candies. I'll go ahead and create a new array here and I'll call it candies. New array, and I'll set this equal to the length of num people. Dot fill with 0. Okay, so the first time around, right, we have person index, which now we know that based on this, the new index really will just be, let's see, person index is, yeah, we actually need a couple things here. We need person index, and I guess we'll also just need a normal index. Let index equals 0. Person index is going to be index modulo num people, just to initialize it to this. And now I'm thinking that we can do, okay, so the first thing, here we have 7 candies. Can we give total candies to this person? Yeah, we can, because it's less than or equal to candies. So I think we can say if total candies is less than or equal to candies, then what do? We say here candies at person index is equal to total candies plus plus. And actually, we should say plus plus total candies because I want to add 1 to total candies every single time. Right? So the first person, candies at person index, will just be 0 modulo num people. This will be 4 is equal to total candies. So this is now 1. Okay. Now for person index, what I want to do now is we should say we're always going to be going up. I feel like I'm going to have an if and else in here, but I also feel like index, this is always going to be increasing, and person index will just be the same thing again. Person index equals index num people. This handles our looping, right? So if total candies is less than or equal to that, we can say candies person plus plus total candies, and then for candies, we should subtract total candies. And then if we ever get to a place where that's not true, then we should just be able to say candies at person index just equals to the remainder of candies, whatever we have left. Candies at person index equals candies, less than or equal to. If total candies is more. And now do we just break here? I guess we can just break here. I feel like we can break here. This is sort of like a high level. But let's now do what I always do. Let's go through an example. So we have this array that we start off with. It's of size 4 because that's what num people is. So the thinking would be to find the number of rounds, candies in each round, candies in each person, and candies in the last person. Yeah, no, I think you're on the right track, yeah. I don't think we necessarily need to find the number of rounds. We should just keep, I think the main condition is like we should just keep going as long as we have candies to distribute. I think the two main things in this question, really one of the big hurdles is making sure that we don't go out of bounds. So that's why we use this person index thing to help us out, always go back to the beginning. So yeah, I think that's the main thing, just figuring out like how many times can I continue distributing candy as long as I have candies left. Also making sure that if I reach the end of my array, I go right back to the beginning. So if we are here, we have a couple different variables here, right? We have index. I'm going to do what I always do. Index, person index equals 0, total candies equals 0. So this is where index is here. While candies is greater than 0, let's also make sure we write candies. This is going to be 7. So we're just going to go through this whole entire loop here. While candies is greater than 0, yes it is, right? Because it's 7. If total candies 0 is less than or equal to candies 7, then what do? We say candies at person index, which we know is 0 to begin with, equals plus plus total candies. So we increase total candies by 1, and then we set 1 here. And then from candies, we subtract total candies. So now we have 6 that we can give. And now we say index plus plus, and person index will be 1 modulo 4, which is still 1. So while candies are greater than 0, 6 is greater than 0. While total candies, which is 1, is less than or equal to candies, we say candies at person index equals plus plus total candies. We increment total candies. We set this to 2, and now we say candies minus or equal total candies. So now this is 4. Let me remove my DevTools here. Okay. And now again, we do index plus plus. We have our person index. We're all good there. While candies is greater than 0, which it is, total candies less than or equal to candy. 2 less than or equal to 4. Yes, that's true. Candies at person index equals plus plus total candies. So increment total candies to 3. Set this to 3. Now we say candies minus total candies. Right? So 4 minus 3 is 1. We increase our index. And we have our person index again. While candy is greater than 0, it is greater than 0. If total candies is less than or equal to candies, which is not, now we just say candies at person index equals candies. This is just 1. And I think we just break there because total candies is only going to increase from here on out. So I almost want to say that this could be true, but I'm a little bit skeptical. I'm going to return candies here because I know that's what I want to return at the end. Now I want to do the same thing for this next example. This example is going to be way more interesting. So Candies is 10, index is 0, person index. We have total Candies of 0, and we have 3 people this time. All right, let's go for it. All right, Candies greater than 0. Yep, total Candies, 0 less than or equal to Candies. So we increment total Candies by 1, and we add 1 here. And now we remove 1 from here, so we have 9. Increment index, that's 1. Person index is 1. I think now this example will show you better why we have 2 of these. Okay, Candies greater than 0, it is. If total Candies is less than or equal to Candies, 1 less than or equal to 9, yep. Candies of person index equals plus plus total Candies, so we add 2 here. Total Candies is 2, and now Candies equals Candies minus total Candies, so now this becomes 7. We increase index and person Candies, or person index. Come to the next one. Candies greater than 0, 7 greater than 0, it is. Total Candies less than or equal to Candies. 2 is less than or equal to 7, so that's fine. Candies of person index plus plus total Candies. Increase this to 3, set this to 3. Now we subtract 3 from Candies, so we're here at 4. All right. Now check this out. Now we're going to increase the index, right? So now index is at 3. Okay. But if we do 3 modulo 3, that gives us 0. So our person index is 0, right? Because that's what the modulo helps us out with. So even though the index is still increasing, we can always just get back to the beginning. Okay, so Candies greater than 0, it is. Total Candies less than or equal to Candies, yep, that's true. Candies of person index, which is at 0, is plus plus total Candies. So we do a 4 here, we add a 4. You see now, check this out. This shouldn't be Candies of person index, right? Should be whatever we had there previously plus the new amount. So I think it should be probably what we should do. Let's think about this. We should increment it first. Here we should say total Candies plus plus, and then Candies of person index. Here we can just do plus or equal total Candies. Because now in this case we increment, right? We incremented our total Candies to 4, and now we add 1 plus 4, which makes us 5. Now we subtract 4 from Candies at 0. Increment index again, so that's 4. Person index will just become 1. But now in this case, Candies is no longer greater than 0. Right, so it's almost like 2 cases. Like you realize that we never got to this else right here, but we did make it to this condition here. So it's almost like 2 things. It's a little bit tricky because they gave us a nice example where it would almost go into both. So let's try this solution out, and let's see what we can get. Const Candies. Oh, it doesn't like. Okay. Let's see. What's like a good output? I guess we can just say distributed Candies. Distributed distribute Candies. These are my distributed Candies. So here, let's see. While Candies is greater, I only want to set total Candies less than or equal to Candies. Okay, that's fine. Here we do this. Here we do that. Nope. What happened? It's equal to Candies, and then I return distributed Candies. 1, 2, 3, 1. All right. Let's see the next one. 1, 2, 3, 1, and 5, 2, 3. All right. Let's go ahead and run this. I think the stream keeps reloading. Oh, I hope not. Are you guys still able to hear me? Oh, we got this one wrong. Can you guys still hear me? Let's go ahead and see what's happening on YouTube land. Let's see. Checking the live stream right now just to make sure we're all good. Still says we're live. Users will experience buffering. All right. Yep, I see. Enough video. Okay, the stream status is poor. I think the stream keep. Okay. Yeah, I am getting a notice from YouTube. It's telling me that the stream status is poor. Hopefully you're all not losing that much. I know before we've had issues with like frame drops. I really hope that's not the case here. If I might have to go ahead and like tweak my settings again to make sure everything's good. But yeah, let me know if everything is working fine. I'll keep those stats up. Hopefully we can just keep going. Yes. 60 and 4, 15, 8, 15, 18, 5, and 12. So it's almost like we... What can this one be? Okay, nice. Output is this. We have 60 and 4. I'm going to try to make this greater than or equal to 0. Should it matter if it's greater than or equal to 0? I mean, could that be... Oh, that changes a lot. There's got to be something here that I'm not... I wonder what's happening. If it's less than or equal to Candies, do that. Else just set it... Oh, wait a second. I think here I need to do plus or equals the amount of Candies left. Maybe I need to do the same thing there. Okay, that could have been it. Let's submit this again and see. Oh, so close, guys. So close. We are super close here. I wonder if, like, can there still be a case where... Okay, let's... Now we're going to try this one out. 90 and 4. 28 and 27, so I'm off by 1 here. 28, 18, wow. What could that be? Plus or greater than Candies, plus or equals Candies. Should I still be... Maybe we should always do this. Candies minus equals total Candies. Is that going to be... I'm just curious. Oh man, 21, 24, so we're missing. Oh, it's the if statement. Well, total Candies less than or equal to Candies. Perhaps. Yeah, we're just going to mess around with some things here. Let's see. I thought if it was the same, because it could be the same. Oh, but yeah. Yeah, I think you're onto something, Rashawn. Now, why is that, though? If total Candies is less than or equal to Candies, only if it's less than Candies. Why can't I just distribute? Oh, I guess if it's less than or equal to, then I'd be giving them more than they could actually have, right? Is that why? Let's see. Whoa. That's wild. Look at that, guys. 100%. Man. Very, very cool. Oh, nice. Yeah, I saw that you just sent me something on Discord. Super cool. I think that's happening because if it's less than or equal to, like if I have 4 Candies and there's 4 Candies left, if it's equal to, that means that I would be actually giving them 5 because I'm incrementing the amount that I have here, right? So I'd be giving them more Candies than are left. So it always needs to be less than Candies for me to be able to give them more. I think that's what the issue is here. But look at this, guys. This is, whew. This is like, doesn't really happen a lot. So very, very cool. I'm happy with this question. I mean, the time complexity of this question, does just run? I don't know if this is like, whoever's good at math here, right? It's not going to be linear. I don't think this is linear. This is only running, like if it's 7, 6, 4, 3, or 4, 1. Can someone good at math tell me what this is? Right, because this would be 20, 19, 17, 14, 10, 5, 0. There's got to be some like, I know, isn't there like a math? Is this like a geometric sequence or something? Or arithmetic sequence? Arithmetic sequence. A plus 1, 3, 5, 7. Yeah, anyone that's good at math on the stream, is this the time complexity of like some arithmetic sequence? That's what I'm thinking. I feel like the space complexity here is just equal to whatever num people is, but let's see discussions here. Easy code with explanation and analysis. All right. Increase each giving them up by 1 till we run out of candies. Cool. 1 plus 2. Oh, here we go. Someone did it. Oh, wow. Okay, so give less than square root of 2 times candies. Is this like, does this mean roughly equal to, or is this like a not? Each column's value, min candies in order to add last remaining candies. Yeah, this, I have to do something like this. For candies, give plus 1. Just change the while condition. Yeah, this is nice. This is a trick I don't use as often, especially when doing like the if and else here, but small syntax things that are nice, but I don't think it's just, I don't think so, right? Because, by the way, answering Rashawn's question, I don't think it's linear because, like I said, if we have like, imagine we have 100, it's going to take a while, but the first time we're going to subtract 1, then we're going to subtract 2, then we're going to subtract 3, then we're going to subtract 4, then 5, then 6, 7, 8. That's 8, right? Wait, what? No, 77 minus 8 is 69. Then minus 9, minus 10, minus 11, minus 12. So 39, 27 minus 13 is 15, minus 14 is 1. Right? So this doesn't run 100 times. That's like the while loop right here. So I think it's like some, because we're always giving them one more candy than before. So however we represent this looks to me like some sort of arithmetic sequence or something. So if we can represent it like that, perhaps, but I'm happy with this answer. And I think we're 1 away from 200. So since we have about 10 minutes left, let's wrap up this stream on 200. Not only are we, I mean, yeah, we're almost, oh, that's right, because this one now, that's a medium. But yeah, almost 200 easies. That's wild. String matching in an array. Let's see what we got. All right, so given an array of string words, return all strings and words, which is a substring of another word in any order. Crazy. Let's see. String words is a substring of words J if it can be obtained removing some characters to left or right of words J. So as is a substring of mass and hero. Yeah, this is interesting. So mass is not, we got to as, that's mass, and also mass and hero. Oh, and hero is a substring of superhero. I mean, could we do this with a try? Maybe? Like if I find that string, that's tough. Return all strings and words, which is substring of another word in any order.